This is part 2 of the 53-word challenge for Llama 3.3, 70 billion model, in providing a list of 53 words, starting with W and H, in a numbered list sorted alphabetically, where there should be no repeat words in the list. The first test saw success from the model, but we wanted to further prove that it can indeed succeed on another session. Go Llama, go! Indeed, Llama 3.3 70 billion model was able to repeat the success for which it undertook the first time around. Pre-trained language models, LLMs, such as Llama 3.3, 70 billion, are AI models that have been trained on a large corpus of text data, typically billions of words or sentences. The purpose of pre-training is to allow the model to learn patterns and relationships within the data, such as understanding language structure and context. The most common approach for pre-training LLMs is using unsupervised learning techniques, where the model learns to predict the next word in a sequence based on the previous words in the text. This allows the model to learn representations of language that capture semantic and syntactic information. After pre-training, the model's weights are frozen and it can be fine-tuned on specific downstream tasks, such as question answering or text summarization, using smaller amounts of task-specific data. This approach helps to improve the model's performance in targeted applications, while reducing the amount of training data required. Instruction-tuned generative models like Llama 3.3, 70 billion, are a type of deep learning model that is specifically designed to generate output based on specific instructions or prompts provided by the user. The key feature of such models is their ability to understand and process natural language instructions in order to create text, images, audio, or other forms of content. The main components of an instruction-tuned generative model include 1. Natural Language Processing, NLP module. This module enables the model to comprehend and interpret human-generated instructions or prompts. 2. Generative Model. The core generative component of the model is responsible for creating output based on the processed input, such as text, images, etc. 3. Training Process. The model is trained using a large dataset of diverse content along with corresponding instructions to learn how to generate outputs that adhere to the given prompts. And 4. Inference Engine. During inference, the model processes user-provided instructions and generates output based on its learned patterns and knowledge. Instruction-tuned generative models are being actively researched and developed due to their potential applications in various domains such as creative writing, image generation, content creation, chatbots, and more. Some popular examples of instruction-tuned generative models include Text-to-Image, GPT-3, Generative Pre-trained Transformer 3, and DALL-E, Deep Artificial Agent for Learning Images. The future is bright for up-and-coming AI models to work alongside and be guided by humans.